And the first question says the cost of a ticket to watch a basketball match is $67.60. The total money received from ticket sales for one match is $1,183,000. Find the number of tickets sold for this match. So for the number of tickets, we'll divide the total money by the price of one ticket. And that's going to give us $17,500. Then it says the cost of one ticket at $67.60 is 4% more than the cost of one ticket last year. Calculate the cost of one ticket last year. So if 67.60 is 4% more than the cost of one ticket last year, that means 67.60 is basically 104% of X, X being the cost of one ticket last year. So 67.60 times 100 divided by 104 equals to X. And that means the cost of one ticket is going to be $65. Then it says the number of seats in the basketball stadium is 20,545. The number of seats sold for the first match of the season is 19,340. Calculate the percentage of the seats in the stadium that are sold. So simple, you just divide 19,340 by 20,545 and times that by 100. And that is going to give us 94.1%. So that is the percentage of the seats in the stadium that are sold. Part C says the team plays 41 matches. For the 41 matches, the mean number of seats sold per match is 16,440. The total number of seats sold for the first 21 matches is 329,000. Calculate the mean number of seats sold per match for the last 20 matches. So first, let's find the sum of seats for the first 41 matches. So sum over number of events is basically equal to mean. So we have 41 matches, so sum divided by 41 equals to 16,440. So sum of seats is going to be 16,440 times 41. Sum of, and that's going to give us 674,000. That is the sum of seats for 41 matches. I want us to calculate the mean number of seats sold per match for the last 20 matches. So let's find the number of seats sold for the last 20 matches. Number of seats sold for the last 20 matches. So going to subtract this from the total amount. And that is going to give us 345,000. So that is the number of seats sold for the last 20 matches. So mean is going to be 345,000 divided by 20. And that is 17,252. So first you find the number of seats sold for the 41 matches. Then using those number of seats, we find the number of seats sold for the last 20 matches. We subtract the sum for 21 matches from the 41 matches. And once we have the number of seats sold for the last 20 matches, we divide that by 20 to find the mean, number of seats sold per match for the last 20 matches. Pardeesi's table shows the salaries of 3 basketball players. Find the difference between the salaries of Tristan and Stefan. This is Tristan. This is Stefan. So we just subtract their salaries. 3.64 times 10 to the power of 7, which is the bigger value, minus 8.27 times 10 to the power of 6. Now, in case you're wondering, how did I decide that 3.64 times 10 to the power of 7 is bigger than 8.27 times 10 to the power of 6? It's because of the power of 10. It's not because 8.27 is bigger than 3.64, it's because of the power. Since the salary for Tristan has a bigger power as compared to that for Stefan, that means this is a bigger value, this is a smaller value. So you can easily take 10 to the power of 6 common. So that's going to be 3.64 times 10 minus 8.27, which is 36.4 minus 8.27. And that is going to give us 28.13 times 10 to the power of 6. Since we have to give it in standard form, so it's going to be 2.813 times 10 to the power of 7. And that's your difference of salaries. The total Joe earns in his salary plus the bonus of X dollars. The total he earns is 102.5% of his salary. Calculate the value of X. So the total Joe earns is his salary plus the bonus of X dollars. Salary plus X is his total earning. The total he earns is 102.5% of his salary. Salary plus X is 102.5% of salary. We need to calculate the value of X. So if we go back to the table, we can see that Joe earns 4.29 times 10 to the power of 6. So that means it's going to be 4.29 times 10 to the power of 6 plus X equals to 102.5 over 100 times 4.29 times 10 to the power of 6. So we solve the right-hand side first, which is going to be 4,397,250. So X is going to be the difference of these two. And that is going to give us $107,250. That is the value of X, which is his bonus. Question 2 says the temperature at midday was recorded at 10 different heights on a mountain. The results are shown in the table. Complete the scatter diagram. The first 5 points have been plotted for you. Let's write down the points first. $100, 3.5, 1250, negative 4.6, 1450, negative 6.4, 1125 and negative 4, 1350 and negative 3.8. So 100 and 3.5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 divisions between 0 and 250. That means one small box represents 25. So 1, 2, 3, 4, that's 100. And 3.5. That's our first point. Then 1250 and negative 4.6. 1250 is this, and negative 4.6 is going to be this. 1450 and negative 6.4. So 1450 is going to be 1300, 1350, 1400, 1450. That's our point. And 1125 and negative 4. 25, 50, 100, 25, and negative 4. That and 1350 and negative 3.8. 1300, 1350. That. So this is a scatter plot. Then it says describe the type of relationship shown in the scatter diagram. Draw a line of best fit. And another reading is taken at a height of 1,000 meters. So you have to find the temperature for that. So for the correlation, as the temperature is increasing, the height is decreasing, which means it's negative correlation. If the temperature was increasing and the height was also increasing, that would be positive correlation. Whenever the graph shows a negative slope, it's negative correlation. And for the line of best fit, we're going to choose those points which equally divide the points. This is my line of best fit because it equally balances the points above and below the line. We can see that there are 3 points above the line and 3 points below the line. Next, we need to figure out the temperature at 1,000 meters. So at 1,000 meters, we're getting negative 2.7. Negative 2.7 degrees Celsius is the temperature at 1,000 meters based on the line of best fit. Part B says the table summarizes times taken by 80 adults to climb the mountain. Calculate an estimate of the mean time. So whenever we have like intervals in our data set, like we have group data, and they want us to find the mean, we have to find the midpoint for each of the intervals. And those values for the midpoint are going to be our x values. This is going to be f, this is going to be x. So between 5.5 and 6.5, we have 6. Between 6.5 and 7.5, we have 7. Between 7.5 and 8.5, we have 7.75. Between 8 and 8.5, we have 8.25. Between 8.5 and 10.5, we have 9.5. Mean is basically sigma fx over sigma f. Sigma fx is the sum of the product of our f and x values. And sigma f is sum of f, which is the frequency. So it's going to be 6 times 8 plus 7 times 15 plus 7.75 times 20 plus 8.25 times 23 plus 9.5 times 14. And this entire thing is going to be divided by the total frequency, which is 18. Should give us the mean value of 7.88 correct with 2 decimal places. Then it says a histogram is drawn to show this information. The height of the bar representing 5.5 to 6.5 is 8 millimeters. Calculate the height of the bar representing 8 to 8.5 for the height. So for this, what we're going to do is that for 5.5 to 6.5, it's 8 millimeters, and to find the height for 8 to 8.5. So let's highlight this first. Eight millimeters for this. So we have to find the height for this interval. So what we're going to do is that we're going to divide the frequency by the class interval. So frequency is 23 divided by the class interval, which is 0.5. So 23 divided by 0.5 is going to be 46. So 46 millimeters is your height. How did we do that? We're basically trying to find the question 3 says triangle PQR is isosceles with PQ equals to QR. The exterior angle of the triangle at R is 142 degrees. Calculate angle PQR. So PQR is basically this one. This is what we have to calculate. So what we're going to do over here is that we're going to begin with first finding this angle. So angle QRP is going to be 180 minus 142 because these two are supplementary. So 180 minus 142 is 38 degrees. Now we know that this is an isosceles, which means two lengths are equal and so are two angles. So this is also going to be 38. So now angle PQR is going to be 180 minus 38 and again minus 38, which is going to give us 104 degrees. That's your answer. Part B says the diagonals of trapezium ABCD meet at E. Show that the triangle ABE is similar to triangle CDE. Give reason for each statement you make. So we have to show that triangle ABE, which is this one, is similar to triangle CDE. So if I color code this, A and C are similar, B and D are similar, and E is similar to itself. So based on this, we know that vertically opposite angles are equal. This angle is equal to this angle. So firstly, angle AEB is equal to angle CED because vertically opposite angles. That is the first one. Then the second one is that we know that this angle is equal to this angle. Angle CDB is equal to angle A, B, D. Because alternate angles are equal in parallel lines. And then this is also alternate angle, this one and this one, which means angle BAC equals to angle BCA. Once again, alternate angles are equal in parallel lines. So these are the three reasons which shows that triangle ABE is similar to triangle CDE. Question 4 says two of the factors of 50 are square numbers. One of these square numbers is 1. Find the square number that is a factor of 50. So if they're both square numbers, then the other is 25. Because 1 times 25 because 50 is 25 times 2 and 50 is also 50 times 1. So these are the two numbers which are square numbers and are factors of 50. Part B says the numbers A and B are written as the product of the prime factors where x and y are positive integers. Find the highest common factor of A and B in terms of x and y. So highest common factor over here is going to be 2 to the power of x minus 1 times 3 to the power of y. Now, how do we get that? If we split A, that's 2 to the power of x minus 1 times 3 to the power of y times 3 to the power of y times 7. B is 2 to the power of x minus 1 times 2 to the power of 4, because x minus 1 plus 4 is plus 3, which is, and then 3 to the power of y times 5. So now if you notice, highest common factors are these and these. So 2 to the power of x minus 1 times 3 to the power of y. And it says find the lowest common multiple of A and B in terms of x. So for the lowest common multiple, it's always the highest number. It's 2 to the power of x plus 3 times 3 to the power of 2y times 7 times 5. So in lowest common multiple, it's all of the bigger numbers. So that's your lowest common multiple. Question 5 says two companies move boxes. Company A charges $0.50 for each box plus a fixed fee of $125. Company B charges only a fixed fee of $350. Find the number of boxes moved when company A charges the same as company B. So if you make an equation for company A, that's 0.50 times x plus 125. 125 is the fixed fee and the variable fee is 0.50 for each box. Box is x over here. Company B is charging $350. So 0.50x plus 125 equals to $350. So we make x the subject. So x would be 350 minus 125 divided by 0.50. And that's going to give us 450. So that's the number of boxes moved when company A charges the same as company B. Next part says the maximum mass a van can carry is exactly 770 kg. The van carries boxes each of mass 4 kg, correct to the nearest kilogram. Find the upper bound for the number of boxes this van can carry. So for that, what we're going to do is, number of boxes will be found by dividing the mass of the van by the mass of the box. Mass of van over mass of box. Now, since we're trying to find the upper bound in division, when you're trying to find the upper bound, the numerator will be upper bound and the denominator will be lower bound. Both the quantities will not be upper bound. The reason why only the numerator is upper bound because upper bound is the maximum value. And in division, you can only get the maximum value if your numerator is bigger than the denominator. That is exactly why only the mass of van will be used as the upper bound and mass of box will be used as the lower bound. So now let's find the upper and lower bounds for each. So the maximum mass a van can carry is exactly 770. The van carries boxes each of mass 4 kg correct to the nearest kilogram. So for this, our degree of accuracy is going to be 1/2, which is 0.5. So lower bound for the box is going to be 4 minus 0.5, which is 3.5 kg. So number of boxes is going to be 770 divided by the lower bound of the boxes, which is 3.5. And that's going to give us 220. Now, the reason for the mass of van we're using 770 is because it says that the maximum mass a van can carry is 770, which means this is already the upper bound of the mass of the van. If it was saying the minimum mass, then that would be the lower bound. So 770 is the mass of van as the upper bound value, and for the lower bound of the mass of box, that's 3.5. And when we divide those, we get 220 as the number of boxes. Next question says a lorry contains boxes of 3 sizes, small, medium, and large. The ratio of the number of boxes for small to medium is 2:7. For small to large is 5:4. The lorry contains 72 boxes of size large. Find the total number of boxes in the lorry. So what we're going to do over here is that 2:7 is for small and medium. 5:4 is small and large. So whenever in a ratios question, you have one similar quantity in both the ratios, what we do is we try to make those quantities the same. So since small is 2 over here and 5 over here, to make them equal, we're going to multiply this by 5 and this by 2. Now, since we're multiplying small with 5 and 2 in these ratios, we need to do the same with the other quantities. By that, what I mean is that 7 gets multiplied by 5 as well, and 4 gets multiplied by 2 as well. So now we have 10 is to 35, and 10 is to 8. So if we write small, medium, and large in a collective ratio, that's going to be 10 is to 35 is to 8. Now going back to the question, they're saying find the total number of boxes in the lorry when the lorry contains 72 boxes for large. Now since the large boxes are 72, we know that 8 times 9 is 72. So if we're multiplying this by 9, for medium we times by 9, and for small we also times by 9. So small are 10 times 9, which is 90. Medium is 35 times 9, which is 350. So total boxes are going to be 90 plus 315 plus 72, which is going to give us 477 as the total number of boxes. Question 6 is triangle A is mapped onto triangle P by a transition of 1, -3. Draw triangle P. So for 1, -3, we have these 3 points on triangle A. So 4, 1 will become 5, -4. 6, 1 will become 7. 4, 1 will become 5, -2. 6, 1 will become 7, -2. And 4, -3 will become 5, -6. 5, -6 is over here. 7, -2 is over here. And 5, -2 is over here. So as you can see, for the transformation of A to B, the triangle has moved 1 unit to the right and 3 units down. Describe fully the single transformation that maps triangle A onto triangle B. So if we compare triangle A and triangle B, we can clearly see that triangle A is enlargement of triangle B. And for the scale of enlargement, the scale of enlargement is going to be 1/2. And the scale of enlargement is going to be -1/2. Why -1/2? Because over here, it's on the negative x-axis. And for the center of enlargement, we connect corresponding points to each other. And we can see that the center of enlargement is 0, 1. So it's an enlargement by the scale factor of -1/2, and center is 0, 1. Part C is transformation M is a reflection the line y equals to -n. Transformation R is rotation 90 degrees clockwise about 1, 1. RMB equals to Q. Draw triangle Q. RMB equals to Q. That means we're going to first transform B using the transformation M. And then we're going to transform that transformation using transformation R. So first, let's reflect triangle B in the line y equals to -1. So y equals to -1 is this. So this point is 2 units away from the line. So it's going to be over here. This is going to be over here. And this is 1, 2, 3, 4. So 1, 2, 3, 4. If we connect the points, this is our transformation M for triangle B. Now, after this, it's saying transformation R is a rotation 90 degree clockwise about 1, 1. So now we transform that new triangle, which is triangle M, at the center of 1, 1, with rotation 90 degree clockwise. So center 1, 1 is over here. So we have to rotate M 90 degree clockwise. If you look at this point, this is 1, 2, 3 horizontally, and 1, 2, 3, 4 vertically. So 1, 2, 3, 4, 1, 2, 1, 2, 3. So that's going to be over here. This is our first point. This point is 1, 1, 2, 3, 4 horizontally, 1, 2, 3, 4 vertically. So now it's going to be opposite 1, 2, 3, 4 horizontally, 1, 2, 3, 4 vertically. So this, and then automatically this point is going to be 2 units away. So this is this one. So now if we connect the points, we can see that this is our final approximation Q. First, we reflected B into the y equals to -1 line, and then we rotated M by 90 degrees clockwise at the center of 1, 1. So that's your answer. The cuboid has dimensions 5 centimeter by 12 centimeter by 8 centimeters. The volume of the cuboid is 480 centimeter cube. Calculate the value of H. So for AD equals to length times width times height. So 480 divided by 60, and it's going to be 8 centimeters. That is your height. Part B says ABCD is a pentagon. AE is parallel to BD. AE is 21 centimeters. BD is 16 centimeters. DE is 8 centimeters. Angle DEA is 90. And angle CBD is 65. Calculate the angle BAE. This. So if we connect point B towards this line, this is a right angle triangle. And this is 16, this is 21, that means this is going to be 21 minus 16, which is 5. And this is 8. So find this angle, we can use SOHCAHTOA. We have the opposite, we have the adjacent. So use tangent, tan of A equals to 8 over 5. So A is going to be tan inverse of 8 over 5, which is basically going to give us 58 degrees. Second part is the area of a pentagon ABCDE is 200 centimeters square. Calculate the length of BC. So this is our pentagon. The entire area is 200. So we have to calculate the length of BC. This is BC. So we know that the part ABDE, that is a trapezium. An area of a trapezium is one over 2 times the height times the sum of parallel sides. So parallel sides over here are 16 and 21, and the height is 8. So 1 over 2 times 8 times 16 plus 21, which is going to give us 148. So now for the triangle, it's a non-right angle triangle. And a non-right angle triangle, the formula for area that we use is 1 over 2 times AB times sine of angle C. This is our angle, and we need the two sides around the angle. So which is basically this and this. We already have this, we have to find BC. It's going to be 1 over 2 times BC times 16 times sine of 65. So total area of this pentagon would be the sum of these two. So 200 equals to 148 plus 8 BC sine of 65. So that's going to be 200 minus 148 equals to 7.25 BC. So 52 divided by 7.25, which is going to give us 7.17 centimeters. That is the length of BC. Question 8 says, complete the table for y equals to 2 to the power of x over 5. So y equals to 2 to the power of 5 over 5. which is going to give us 6.4. That's the answer. Then it says on the grid, draw the graph of y equals to 2 to the power of x over 5 for x greater than equal to 0 and less than equal to 5. So let's write down the coordinates. 0, 0.2, 1, 0.4, 2, 0.8, 3, 1.6, 4, 3.2, and 5, 6.4. So 0, 0.2 is going to come over here. 1, 0.4. Over here. 2, 0.8. This. 2, 0.8. Then 3, 1.6. That's 3, 1.6. 4, 3.2. And 5, 6.4. So now we just connect the points. That's our graph. Then it says 2 to the power of x plus 3 equals to 100. So that 2 to the power of x over 5 equals to 5 over 2. So 2 to the power of x plus 3 equals to 100. So first we split this into 2 to the power of x plus 2 to the power of x times 2 to the power of 3. Because whenever we have similar bases being multiplied, we add the powers. So if we split this, it's going to be multiplied by 2 to the power of 3. That's going to be 8. So now 2 to the power of x equals to 100 over 8. It simplifies to 25 over 2. So now 25 can be split into 5 times 5. So that's 5 times 5 over 2. That's going to be 2 to the power of x over 5 and 5 over 2. Just split it and bring 1 5 to the other side as it is in the question. So 2 to the power of x over 5 equals to 5 over 2. Then it says by drawing a suitable line on the grid, solve 2 to the power of x plus 3 equals to 100, which means we're going to put our graph, which means we're going to draw a line of y equals to 5 over 2, and whatever the intersection points are between the graph and the line, that is going to be the solution. So let's go back to our graph now. So we draw a line at y equals to 5 over 2. So that's 2.5. So that's going to be over here. That's giving us a solution of 3.1, 2, 3, 4, 5, 6. X equals to 3.6. That's our answer. This is a sketch of a graph y equals to a plus bx minus x squared. The graph crosses the x-axis at integer values of x. Find the value of a and the value of b. So to find the value of a and b, what we're going to do is we substitute this point 0, 7 in the equation first. So that's going to be 0. So that's going to be 7 equals to A plus B times 0 minus 0 square, which gives us 7 equals to A. So we have y equals to 7 plus bx minus x squared. Now, since they're integer values, which means these 2 points at this point and at this point, y is 0. So 0 equals to 7 plus bx minus x squared. Now, if we rearrange this to make x squared positive, it's going to be x squared minus bx minus 7 equals to 0. Now, if you think about solving this, like using middle term breakage, we know that coefficient of x squared is 1 and the constant is negative 7. So 7 times 1 is 7. And factors of 7 are only 7 and 1. So which means it's going to be x squared minus 7x plus x minus 7 equals to 0. Then we're going to take x common, x minus 7 plus 1 common, x minus 7, which means it's x minus 7 times x plus 1 equals to 0. So this point over here is going to be x equals to negative 1, and this is going to be x equals to 7. Simply looking at the equation of x squared minus bx minus 7 equals to 0, we can easily tell that there are no other factors involved over here. So using middle term breakage, we can easily guess that 7 and 1 are the factors, and then we just make our equation, solve it. And using that, we can see that b is negative 6 because negative 7x plus x is negative 6, and a is 7. So these are your answers. Question 9 says diagram shows the position of 3 ports A, B, and C. The bearing of port B from port A is 107 degrees. The bearing of port C from port A is 192 degrees. AB is 176 kilometers, AC is 132 kilometers. Find the bearing of A from B. So the bearing of A from B, we know that this is 107. So if we draw the compass at B, we're trying to find this bearing. In parallel lines, alternate angles are equal, which means this entire thing is 107 because this north and this north are parallel and AB is the transversal. So this angle is going to equal to this angle. So bearing for the first part is going to be 180 plus 107. It's going to give us 287 degrees. That's for part A. Then it says calculate BC. So to calculate BC, we first connect the 2 points. This was 107. And the bearing of C from A is 192. Which means this is 192. So to find the angle over here, we subtract 192 and 107, which give us the angle of 85. So we need to find BC. We have 2 lengths in the angle between them. We can easily use cosine rule to find BC. BC square would equal to 132 square plus 176 square minus 2 times 132 times 176 times cos of 85. That's going to give us 48,400 minus 4,049.6. You multiply 132, 176 and cos 85 together. Don't do it separately. Just multiply them together and then you subtract that result from the sum of these 2 square numbers. So that's going to give us square root of 44,350.4 and that's going to be 210.6 kilometers. That is your length of BC. Then part C says, port B leaves port B at 10 a.m. It sails directly to port A at an average speed of 48 kilometers per hour. Port C leaves port C at 10:15 a.m. and it sails directly to port A and arrives there 7 minutes before port B. Find the average speed of both C in kilometers per hour. So first, we find the time for port A, like how much time it takes for it. For port A, so that's going to be distance, which was 176 divided by the speed, that's 48. That's going to give us 3.66 hours, which is basically equal to 220 minutes. We multiply 3.66 by 60. That gives us 220. Then you find the time of port C. For port C, it says that port C leaves port C at 10:15. So from this to 20, and it's arriving 7 minutes before. So we subtract 7 and then we subtract 15 as well. Why? Because port B, sorry, this is B. Because port B leaves port B at 10 a.m. and port C leaves port C at 10:15 a.m. So we have to remove these extra 15 minutes from 220. Then we have to remove the 7 minutes because it's arriving 7 minutes before port B. So that gives us the time that it takes for both C to arrive at the port. So that's going to be 198 minutes, which in hours is going to be 3.3 hours. If the time was, if like the departure time was equal for both B and C, then we won't be subtracting 15 minutes. But since it's leaving 15 minutes later, so we need to remove that time as well from 220 to find out how much time it takes for both C to reach port A. So now for this, average speed is going to be 132 divided by 3.3. Distance for C was 132 kilometers, divided by the time, which is 3.3 hours. That's going to be 40 kilometers per hour. That is your answer. So in question 10, it says that R equals to 4p plus 3t over 2. Find the value of p when R is 10 and t is -2. So we just substitute the values in the equation. 10 equals to 4p plus 3 times -2 over 2. So that's 10 times 2 equals to 4p minus 6. 20 plus 6 equals to 4p. 26 equals to 4p. So p is going to be 26 divided by 4, and that's equal to 6.5. Part B says the diagram shows a quadrilateral. Form an equation in W and solve it to find the size of the largest angle of the quadrilateral. So this quadrilateral has 4 sides, obviously because it's a quadrilateral. So sum of angles is going to be 360. So 360 equals to W plus 2W plus W plus 10 plus W minus 50. So 360 equals to 5W minus 5. 360 plus 5 equals to 5W. 365 equals to 5W. W is going to be 365 divided by 5, and that is 146. So the largest angle is going to be 2 times 146, which is going to be 292 degrees. That is your largest angle. Part C is simplified 2k square minus 5k minus 3 over k square minus 9. So we have a quadratic equation in the numerator and denominator. So if you solve the quadratic equation in the denominator, that's basically difference of perfect square. So k square minus 9 is going to be k minus 3 times k plus 3. And for the numerator, 2 times 3 is 6. So factors of 6 are 3 times 2 and 6 times 1. Now we know 3 plus 2 also equals to 5. And 6 minus 1 also equals to 5. So if we use 3 plus 2 first, 2k square minus 3k minus 2k minus 3. Now if we factor by grouping, first two terms make one group and the last two terms make another group. Between the first two terms, we have k common, so 2k minus 3. And between the last two terms, we have negative 1 common, 2k plus 3. Now, if you can see, we cannot further factorize it because the brackets don't have the same terms or the same signs. Hence, 3 and 2 are not the right factors to be chosen over here. So now let's choose 6 and 1. 2k squared minus 6k plus k minus 3. Between the first two terms, we have 2k common. So k minus 3. And in the last two terms, we have plus 1 common. So k minus 3 again. Now you can see that both the brackets have the same terms with the same signs. So we can take k minus 3 common and we'll have 2k plus 1 inside the bracket. So over here, we're going to have 2k squared minus 6k plus k minus 3, which is going to be 2k bracket k minus 3 plus 1 bracket k minus 3 over k minus 3 times k plus 3. That's going to be k minus 3 times 2k plus 1 over k minus 3 times k plus 3. K minus 3 get cancelled out and we're left with 2k plus 1 over k plus 3. That's your answer. Then it says solve 2 over x plus 3 plus 5 over x minus 2 equal to 1. Show all your working, give your answer correct to 2 decimal places. So whenever it says correct, give your answer correct to 2 decimal places, that means we'll have this quadratic equation and we'll have to solve using the quadratic formula. So to derive the quadratic equation, we're going to first solve these two fractions with unlike denominators. So whenever we're adding fractions with unlike denominators, we make the denominators equal. So first fraction will be multiplied by x minus 2. And the second fraction will be multiplied by x plus 3. So that's going to be 2 times x minus 2 plus 5 times x plus 3 over x plus 3 times x plus 2. And that equals to 1. So that's going to be cross multiply x plus 3 times x plus 2 equals to 2x minus 4 plus 5x plus 15. Expand the bracket. X times x plus 2 plus 3 times x plus 2 equals to 2x plus 5x is 7x. 15 minus 4 is 11. So now x squared plus 2x plus 3x plus 6 equals to 7x plus 11. Bring everything on one side. X squared plus 5x minus 7x plus 6 minus 11 equals to 0. X squared minus 2x minus 5 equals to negative. So that's going to change this sign. Minus, minus, and this is going to be 17. This is also going to be minus So cross multiply x plus 3 times x minus 2 equals to 2x minus 4 plus 5x plus 15. X times x minus 2 plus 3 times x minus 2 equals to 7x plus 11. That's x squared minus 2x plus 3x minus 6 equals to 7x plus 11. X squared plus x minus 6 minus 7x minus 11 equals to 0. There's going to be x squared minus 6x minus 17 equals to 0. So now we use the quadratic formula to find the values of x. A equals to 1, B equals to -6, and C equals to -7. So -6 plus minus square root of -6 squared minus 4 times 1 times -17 over 2 times 1. That's going to give us 6 plus minus square root of 104 over 2. So one value is going to be 6 plus square root of 104, which is 10.198 over 2. That's going to give us 8.10. And the other is going to be 6 minus 10.198 over 2, which is going to give us -2.10. So these are the two values of x corrected to decimal places. Question 11 says on any day in January, the probability of the temperature to weather station is above 14 degrees Celsius, 0.35. There are 31 days in January. Find the number of days in January when you would expect the temperature to be above 14 degrees Celsius. So for this, you just multiply 0.35 to the number of days, which is 10.85. So that is approximately 11 days. Then it says the temperature on 2 consecutive days in January is recorded. Complete the tree diagram. So for this would be 1 minus 0.35, which is 0.65. So same 0.65 over here, 0.35 over here, and 0.65 over here. Find the probability that the temperature is above 14 degrees Celsius on both days. So on both days, that's basically going to be this and this. So that's 0.35 times 0.35, which is 0.1225. Then it says find the probability that the temperature is above 14 degrees Celsius only one of the 2 days. So for one of the 2 days, so that's going to be this and this and this. So that's 0.35 times 0.65 plus 0.65 times 0.35 again. So that is going to give us 0.455. That's your answer. In a group of 14 children, 8 wear red t-shirts, 1 wears a green t-shirt, and 5 wear blue t-shirts. 2 children are chosen from the group at random. Find the probability that they wear different colored t-shirts. So if they wear different colored t-shirts, it's going to be 8 over 14. 2 children are chosen, right? So then it can be 1 over 30. So this is red and this is green. Or it can be 8 over 14 times 5 over 13. So now it's red or blue. Then it can be 5 over 14 or 1 over 13. That is blue and green. So now for this, the order can also change. Like we can choose, like in the first combination, it can be green or red. This can be blue first and red second, and then can be green first and blue second. So all of these will be multiplied by 2. Because if you make another for the opposite combinations, problems are still going to be the same. So you just multiply these by 2, and that is going to give us 53 over 182 times 2, which is 106 over 182. And that's your probability that they wear different color t-shirts for the 2 children chosen from the group at random.